Welcome to today's webinar. The topic today is consideration of construction stages in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the content of the website, the German and English webinars, customer projects, and so on. I will be the moderator today, and I will answer your question together with Alexander. Adrian will do the presentation, but yeah, my two colleagues can introduce themselves.
Yeah, hello, my name is Adrian. I'm responsible at Dlubal Software Company for the customer support and product engineering or development, and especially in the area of concrete design, but also in the area of construction stages. And yeah, this is the reason why I would like to show you today the construction stages.
Hello together, also from my side. My name is Alexander Mayhofer. I'm responsible for the development of the product's concrete design, also TDA, geotechnical analysis, and so on. And today I will answer your questions in the chat.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. I see something about how you can ask questions, at least for the attendees who participate the first time or the first time with the new GoToWebinar interface. You need to click on that button here, and then you can enter your question below. You can also do or adjust the audio settings, etc. Yeah, and if you enter a question, we will answer you. Yeah, our way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's all from my side. I hand over to Adrian.
I will take the screen. Yeah, one moment. One moment, this one. So you should see my screen now.
Yes, the RFEM interface.
Yeah,
now the
then,
PowerPoint.
Yeah,
Okay, thank you.
That's good. So the content of today's webinar is the construction stages, as mentioned. I will show you something about the definition of the construction stages and then about some new feature of the construction stages analysis. But also I would like to introduce and or show the combination with the TDA add-on, so with the time-dependent analysis. And we do I will show like 3 different examples. One quite simple example in the beginning to show some basic principles of the construction stages analysis in combination with the time-dependent analysis, especially regarding long-term deflection or long-term behavior regarding creeping. We do afterwards. I will show a little bit bigger example with a building known from the first stages webinar, and at the end I will show also again a smaller example with a new feature in construction stages regarding the phased cross sections. Yeah, and for all these examples, it's quite similar. I showed the input, the calculation, and then we take a look at the results. So I switch over to RFEM for this simple example. I start from 0, so I will create a new file and do the complete input. So like, webinar, I guess it's webinar, doesn't matter what the name is. Here in the second register, I activate the construction stages. and this time also the time-dependent analyzers. And I say OK. And then I will do the input for a quite simple structure, let's say a simple beam, which will be changed during the construction process or during time to a continuous beam. So I will create, let's say, new section. Should be, it doesn't really matter to show the principle, but I will, could be some part of a slab also. I will use this rectangular cross section of made of concrete, of course, and should be I have to define the structure in RFEM, how it is in the end of the construction process or at the end of time. So I will define it as a continuous beam. So some horizontal fixed nodal support at the beginning, and then the other nodal supports could be moved in horizontal direction, are able to move. So maybe I show them a little bit larger. So this is the example, as mentioned, quite simple. Because I want to consider the long-term effects due to creeping, I will activate the creeping in the material. So you have to activate it here by editing the material, and in the second register you will find the creeping. You also find, if you choose the section, this is the one I have defined, you see the creeping coefficient over time, and you also have the input, for example, regarding relative humidity for the creeping. Yeah, and you have a diagram which shows how's the creeping coefficient developing or over time. So this is the structure. As load, I will only use the self weight. There's no additional load because this is enough to show the behavior I would like to show here. So then the next step would be the input for the construction stages. And there are like two places or two different parts of the input for construction stages. The first part is the structure side, so the definition of what part of the structure is active in which construction stage. And the second part will be the load side. We are starting with the structure side. So in the beginning, it should be a simple beam. So I activate all member. Here in the main dialog, I can switch on what kind of structural elements I would like to consider. As already mentioned, it's quite simple example. We only have members and nodal supports. So I only activate the member and the nodal supports. In the first stage, the both members are active, but only the first and the last nodal support. So it's a simple beam in the first construction stage. And in the second construction stage, I add this nodal support in the middle. I can choose it or I can say all. Then it's both possible in this case. And in the last construction stage, I say that the time will be changed. So until now, we only changed the structure, but in the last construction stage here, I define an end time of 50 years, which is 80,250 days. Yeah, so this should be the example. I could it would be also possible to define construction stage 2 and 3 together in one step, but I would like to show the results in between for construction stage 2 to show that there will nothing happen if I add this nodal support without adding an additional load. And as mentioned here in this example, there will be only the self-weight acting, and the self-weight is applied in the first stage with activating the members. And that I only want to consider the self-weight. This is something which has to be defined as mentioned for the load side. So I can, for example, switch here to a construction stage and edit the construction stage in the load case and combinations dialog. So here you see again the defined 3 construction stages, and I am in the for the first construction stage I will go here to the second register where I could apply load cases. This is something which is also shown in several webinars before. So we should be today the 5th webinar. So there are 4 older webinars with a bit more complex load situations. So if you are interested here in a bit more complex situations, I would recommend to have a look of to the older webinars. Today it is more about a simple example and to show, as mentioned, the behavior or the combination of construction stages and time-dependent analysis. So once it is, I've activated the self-weight in the first construction stage, you have it in all, or it's active in all following construction stages because it's considered as a permanent load, which is kind of logical for a self-weight, because once it's activated, you could not remove it. Okay, so this should be in the beginning enough to calculate the structure. Maybe I will save before I calculate. It's always, I would also always recommend it. And now I check here the graphic and I see there's something wrong with the definition. This is, you could also check it graphically what's active, and this is exactly vice versa as I would like. Okay, sorry, I deactivated this part. I would like to activate the first and the second, and yeah, now it should be okay. It was my mistake. No, what's wrong here? No, not deactivate. Add. Sorry. 1, 2. Now. This is the good thing. You could always check the input graphically. So I checked here construction stage 1, first and last nodal support is active. Second construction stage, I only add this support in the middle, but no additional load. So I expect that there's nothing changing here. But then in the last construction stage, I consider creeping and the deflection or deformation due to creeping with this additional nodal support here in the middle. And we will see how it influences the results. I will calculate the first construction stage and then see how it behaves. Should be deflection and bending moment typical for a simple beam. I will check it. Yeah, and second stage should be the same, because the nodal support, there's, as mentioned, there's no additional load applied. The deformation and the stress situation, or the internal forces, are the same like for the first construction stage. The only difference is I added this support in the middle. And if I would, for example, now add an additional load, then this support in the middle would be considered or would be active. But the self-rate is existing from the first construction stage. And now I would like to calculate the third construction stage, which only consists of the creeping effect. And here the support in the middle is considered. So to explain it, so due to the deflection of the simple beam, like here, and if I look to the deflection, normally if I would not add the support in the middle and I would consider creeping, the deformation or deflection would just increase in the same characteristics like it is due to the load. But because of the added support in the middle, there is no possibility for the structure to move or to deflect, to bend here in the middle. So due to this, there's some kind of, let's say, restrain and redistribution of the internal forces. And this is what happens in the last construction stage, where I consider the creeping. So here it is, the deflection is the same, of course, in the middle, because the structure could not move anymore here due to the fixed load. It is a little bit visible that the deformation changes in the area of the start and end. When I look at, like here, at the complete results of the deflection, there it's recognizable that here in this area of the beginning and the end, there is a changing of the deflection due to creeping. But what is more interesting is that there is here a redistribution. I now calculated the structure with default settings. It is in the program also possible to have an influence on the calculated time steps, because the program calculates in several time steps and save the results of these calculated time steps. To change the default values, I can open the construction stages again, and I have here the static analysis settings. And with activating the TDA add-on, there's here some additional register with the number of the time increments. Default value is at the moment 5. In the future, there will be also more possibilities here to choose how the time increments are considered. Now there's a linear division of the time, but there will be also the possibility in the future for logarithmic division. So yeah, but yeah, you will find it here then soon, different possibilities. But it's also possible, if I go here to the main register, to save the results of all calculated load increments. And this is something I would like to do. And I can recalculate. And then it's divided by, it's I'm able to show the results of all 5 calculated time steps. And this is here because I used 50 years. It's every 10 years, and I see how the bending moment could change. But here the time is maybe a bit too large. So after 10 years, most of the redistribution already happened. And to show it a little bit more clearly, I will add another construction stage, or I will do it here. I will change the time and add another construction stage. So here I will maybe say 1 day, and then another construction stage at the end with the end time again 18,250 days, 50 years. The program automatically calculates for the several or for the particular construction stage the start time, end time, and the duration, depending on what you are defining. So you could define the end time, or you could define the duration. This is up to you. The program calculates the missing part and is considering it. So now, then I could maybe, show it a little bit more clearly what's happening in the structure. I will calculate the third construction stage with the 1 day, and if I go here through the time increments, or through the results of the time increments, I see that there is here a redistribution, and the structure tries to deflect, but it could not deflect in the middle. So due to this, there's a redistribution of the moment, and also of the support forces and rectangular or of the shear forces. So this is here. This may be a bit more clear. It's also possible to show the part, like the delta result, related to the previous construction stage. I will show this later with the combinatorics. Now I want to have a look at the support reactions then, and maybe the shear forces. Then it's also visible what happens here, that the structure tried to deflect, but it could not. And then here, this support in the middle is activated. Oh, one moment. Here, maybe here it's better. Here. And then due to increasing time, the support force is also increasing here, and for the first and last support, it's decreasing. So maybe we go to the, as mentioned, to the combinatorics. It's possible to create automatically the combinations for the construction stages, or for some construction stages I would like to consider. Therefore, I have to go to the combination wizard here in the design situations, the combination wizard. But before doing this, I will remove these 2 design situations I don't need here in this example. I only want to show the characteristic results here. And then I will edit the combination wizard, and here it is possible to activate the automatic combinatorics for a construction stage. I have to choose here the same method like what is used for construction stages, and activate the initial state. It is at the moment the construction stages are considered in the as an initial state, or the combinatorics are considered as an initial state there will be very probably a change in the future that they get a separate entry, so that you have in the future here not only consider initial state, there will be an additional part, consider construction stage. Yeah, and here I could choose for what combinations, for what construction stages I would like to generate automatically the combinations. I choose here the last 3 construction stages. This is a little bit, yeah, as mentioned, simple theoretical example. And the goal is, or what I would like to show is only what kind of results I have for the combination, and that I have an additional option regarding showing, I call it always delta results, so like results related to the previous construction stage, and not seeing only the results at the end of the construction stage. So I go through here and check if the action combinations are generated correctly, and it looks good. And here I now have the combinatorics for these 3 construction stages, so for the 2, 3, and 4. And also for the ULS, yeah, to be honest, I don't need it here in this example, but I left it active. What you see here is also that the program, if necessary, calculates or generates additional auxiliary combinations. Here, for example, because I started with automatic combinatorics for construction stage 2, so I don't have a combination for construction stage 1, but here for the ULS, I have the permanent load case 1, the self weight considered with load factor, with safety factor. So the program creates an auxiliary combination to have the results with factor also for construction stage 1. But I will here have only a closer look to the characteristic combinations. So I will calculate the results. For the combinations. And here in this example, I did it only to show, as mentioned, the delta results. In other examples, in older webinars, there's shown a little bit more about the combinatorics. So if you would like to know more, I would recommend the older webinars. Here, the main thing is that I would like to show, for example, if I go to the result of the 3rd construction stage, this one day where I have the same results now, like for the construction stage, I could here change the type of result. And normally we see by default the final results, but I could also choose here different to initial state, and then I see the part, only the part of the bending moment due to the creeping and the redistribution of the internal forces. So yeah, I could here switch between these 2 types of results. Yeah, maybe for those who want to know a bit more how this is done internally, the calculation, I give some quite short background information, but maybe it helps if you want to read more about the theory, which is used here in the background for the calculation. Yeah, the TDA, time-dependent analysis, uses here a rheology model, which works based on so-called Kelvin-Maxwell chains. This means that, for example, due to creeping or due to the consideration of creeping, there is not only a simple reduction of stiffness, like it could be also done in a more simple way to consider creep. Here there are used elements consisting of an elastic and viscoelastic part. So elastic part for the load, if I apply load, and viscoelastic part to consider this long-term effects like here creeping. So this allows to consider the long-term deformation or long-term effects much more exactly here with TDA. And it allows, for example, also that you could apply additional loads during the construction process. And you could consider individual long-term behaviors for all these applied loads separately. So this is something, yeah, which is quite, quite exactly method for considering the long-term effects. And this is what it's, yeah, about the TDA add-on. Yeah. So this should be maybe enough for the first simple example. I will now move to a bit more complex example. This is something which is already defined. This is exactly the same example like we've showed in the first construction stages webinar. So if you want to know about the background or about the input of the construction stages, for this example, you could have a look at the first construction stages webinar, which you find on our homepage. Here I would like to add to the existing structure with the construction stages the input for the TDA, and would like to see how it influences the results of the calculation. So I will go to the base data, and I always did it. Activate the time dependent analysis. Maybe I forgot it. Okay. Then we do it again. Maybe I saved from the last time. I will deactivate it first, and then I will activate it again. Then I could hopefully show it. And save the results with the input, what is somehow good, but normally I would like to do it here, but it doesn't matter. I can show it anyway. So with activating, the program is a bit too smart. It remembers everything here. So with activating the time-dependent analysis, you have, as it was also visible in the first example, you have here this input for the TDA in the construction stages. And I could define here the times. And as mentioned, the program remembered this time here. But I, for example, can here define different times for the single construction stages, and the program automatically adapts also the timeline. And here, for such an example, it would be, for example, good to use here the duration, like every story needs, for example, I don't know, it's something I just used 28 days for it here. Like it needs 28 days for every single story, and I could do the input here via duration, and the program automatically determines the end time. You could also do the input in in the load cases and combinations dialog. Here you have it's an alternative way to do the input here for the times. And then you could add them and recalculate the structure, including TDA. So I will not show here the calculation because it's like something about, or it should be exactly 20 construction stages, and every single calculation needs about 5 till maximum, I would say 10 seconds, but due to the number of the construction stages, it's a bit too long to show it here. And for this reason, I saved the structure before, including or after calculation, including the results. One time with the TDA and one time without the TDA. So we can have a look at both results, calculation with and without TDA. Here on the left side, including TDA, I will switch to the statistical analysis and maybe the last construction stage. And we can have a look at the deflections. Maybe I will switch off the result sections, which I've used here in the middle of the slabs, and the same here for the other side. Last construction stage. Yeah. And here we have the results without TDA. Yeah, maybe I did it a little bit fast, maybe for the explanation. This is the example from the first webinar, but the background is there's here a concrete core with slabs, concrete slabs, and here at the outside concrete columns. And the background is that due to construction process, or due to not considering the construction process, the slabs will normally hang on the concrete core, but with considering the construction stages, this deflection is it is considered that that the new stories are always placed in the original point, so there is some part of the deflection removed. So here now with TDA, with the creeping effect, I see that here on the left side there's an additional deflection, of course, to the creeping, because I create one story, then I apply the load, and then it starts to creep, and then I build the other story, and then apply the load, and it starts to creep, and this got an influence to the deflection, of course. It is also visible when I show the deflection in the actual direction of the columns. So we can have a look at these results, UX, and you see the deflections in the columns, and that it is here with TDA quite larger. But the interesting part here is now, does it influence the internal forces, which I want to consider for the concrete design, for example. And therefore I could, for example, have a look at the bending moments in the slabs. I have here a result section which I could activate. Maybe I switch on off this and say I would have a look at the bending moments, and the same for the structure without TDA. I deactivate this, activate the result sections, and then I could have a look. how much the difference is. And here for this example, there is recognizable that there is a difference, but it is, yeah, I would say not that big. There's like, I don't know, 0 point something percentage difference. So for such an example, the influence to creeping would not be that high for the internal forces. And I also could have a look at the concrete design. I can switch and have here the results for the concrete design. It's the same principle. I have a result section here in the middle of the slabs and see the required reinforcement at the bottom, and here on the left side also. I also can have a look at the required reinforcement on the top side, like here. And then I could compare if there's a significant difference. But here in this example, it is there is a difference, but it is not that big. But what I would like to show here is, yeah, how to consider the, or wanted to show here is how to consider the TDA in combination with construction stages and the design. And there are structures depending how complex or how high these structures are and how long the construction process is, where you have an influence due to long-term behavior, due to creeping, where there could be a redistribution of the internal forces, like, yeah, shown for the first example. There was a quite significant change. Of course, it was due to the support, due to the added support in the middle. But even if you don't have such significant changes on structure side, there could be changes in the internal in the distribution of the internal forces due to this long-term effects. And yeah, now you are able with RFEM6 and construction stages and TDA to consider such behavior. Yeah, and this is, yeah, what I wanted to show. And maybe as a last small example, or maybe more an outlook on what we are working right now, is I will show a very small example regarding, we call it phased sections, so like cross sections with composed sections. I will create here a very simple example again with cross section, with the cross section type parametric massive 2. Normally in concrete design you use the massive 1 cross sections. Here we have an additional category massive 2, and massive 2 sections are, I will show it, are made of or composed of several parts, where you could activate the parts step by step during construction process. So once I've created a parametric massive 2 section, I can create, when the construction stages add-on is active, and this is the problem here probably, I deactivated it. So as soon as there's a construction stages, or as soon as the construction stages add-on is activated, I can create here, when there is a massive 2 section, I can create a phased section. And this phased section got a, yeah, mother or parent section, which is here now automatically filled, which is the section 1. And in this phase section, I could say there's only one part of the section active, like here, for example, the web. So I could define these two sections and could later activate this section step by step in the construction stages. I will show it maybe like this. Doesn't really matter how it looks. It's only to showing how it works. I create another, quite simple example. Maybe with one part horizontal fixed and the other not fixed horizontal. So like this. Maybe also a bit larger that it is better recognizable. And then I don't do anything more here in the RFEM input. It's a quite simple beam, yeah. But I will show the input in the construction stages add-on. I activate here for construction stage 1, the members and the nodal supports. I say all members, there's only one, all nodal supports. And here for the members, there's the possibility to modify properties of the members. And one property I am able to modify is the section at the for the member. And if I choose this here, the program automatically shows what section is currently active for this member. And here I would like to say in the first step, I don't want to have the whole cross section active. I want only this phased cross section or this part of the structure of the cross section active. So here, for example, the web. And then there's another construction stage. I create another construction stage, and there I modify this member again. Also the section. Now the program knows, okay, before there was section 2, this phased cross section, and now I would like to complete it to this T section and say, okay. And this is something I could now calculate. I have to, before I calculate it, I have to, like in the example in the beginning, I have to apply the load in the first construction stage, the self rate. And then I could calculate it, this structure. And it considers in the first construction stage only the web, and in the next construction stage the additional, let's say blade part or flanges of the cross section. This is possible now for calculating the deflection and internal forces, or all statical analysis results. And the next step is that we are working on the design of such cross sections. And the program is also at the moment able to consider the self rate automatically. There are some additional topics like regarding showing the graphics more detailed. But from the calculation point of view, internal forces, deflections, and so on, you could already use it. And as mentioned in the future, the next step will be the design of such cross sections. I also did here a small, let's say plausibility check, or a small example to explain the results without using construction stages, only that it is a bit more clear what's happening here in the background, and to explain the results. This is possible here because the example is quite simple, so I could make some separate structures to explain the results. So if I have here, for example, construction stage 1, there's a bending moment. There's only the web active in construction stage 1. And this is like the result for this structure. So you have the same bending moment, same deflection. And in the second construction stage, there is added automatically only the part of the self-height of the blade, or of the added section part. And then you get a bending moment here of 30, something about 32. And here I did a separate, let's say calculation. And this is the delta result. So this is the bending moment, which should be added to the existing moment. So this is also the same result. So that if you sum up these both bending moments, you will get this result of 32.16 kilonewton per meter. And also it's the same for the deflection. The resulting deflection is here 1.1, and here it's the same when you sum up the deflection. It's the same. This is only, I did only to explain a little bit what happens here in the background. And in the future, as mentioned, next steps will be the design of such cross section. And the big effort of this feature is that you could use it based on cross sections only for members. So this is also something which was not possible in the past. So it's a quite new feature, and could be especially when the design is also ready, could be used for a lot of for several topics out there, I guess. This should be the last example. Should be some kind of outlook on what we are working right now. And with this outlook, I would like to end my part and hand over to Andreas again.
Yes, thank you, Adrian. I share my screen. Before, I would like to show you where you can find the recording on our website in the next days and the models. I would like to show you this PowerPoint slide. There are also questions about our program and about the main program and the add-ons and so on. If you want to get a non-binding offer, or you would like to book your free product demonstration, just contact our sales team. You can click on that link here, or you can scan that QR code. And our sales team will help you. Okay, then I turn to the website, dlubal.com, and under news and events, you can find here the events and the webinars. So those are the next webinars. CSA, the Canadian standard, CLT building design. That's also in the next week. I present in the next week the regular webinar, most frequently asked questions, answered by Dlubal support team. Then also in the week after next week, I will present the first part of this webinar, modeling and design of steel structures. That's, I think, more for beginners. And the second part in the week after this week, that's for beginners and I think also experts. Okay, then we search for today's webinar. It's already occurred. So you don't need to remember that link. In the next days, you will get an email with your attendee certificate and a direct link to that page. Then you will find the recording in the middle here. You can already download the presentation slides. Yeah, for example, with the link to our sales team. If you want to book your free online demonstration or product demonstration, or if you would like to get a non-binding offer. So, and you can already find the models and can download them. Yeah, and then you can go through the webinar in the next days if you want. Okay, that should be also all from my side. Thank you for your attention. Thanks to Adrian for this nice presentation. Thanks to Alexander for his help by answering the questions. I hope we meet each other in a future webinar. I wish you a nice rest of the day and say bye-bye.
Thank you. Bye-bye.
Bye-bye.